This is Geometry, Unit 9, Lesson 1, Intro to Trig, the rest of the notes for solving triangles. All right, so we want to solve for the missing sides of the following triangles. So we're going to use that table that is on the notes, this table right here, by looking at the ratio of the sides that we have with the acute angle that is given. All right, so our ratios are opposite hypotenuse, adjacent hypotenuse, and opposite to adjacent. So let's take a look at our picture here and figure out what we have to do. So to solve for the missing side, first you have to identify the acute angle. All right, the acute angle that we're working from is this angle right here. This is the 36-degree angle. All right, then from this angle, where are the sides of interest? All right, well, this is a right triangle. So that means that the x is opposite the acute angle. All right, so this is opposite, and we are comparing it to this side of the triangle. Well, since this is the right angle, this side across from it is always going to be the hypotenuse. All right, the hypotenuse is always across from the right angle. Okay, so we are going to use the ratio of opposite to hypotenuse equals opposite over hypotenuse. All right, now we are given opposite is x, hypotenuse is 15. Okay, now since we're dealing with the similar triangles, we want to look at our table and figure out the 36 degrees in the opposite to hypotenuse column. So here is my table that I'm looking at. All right, opposite to hypotenuse is the first column. And I want to go down here and I want to find 36 degrees. All right, 36 degrees is this ratio. The ratio of the sides opposite to hypotenuse of a 36-degree triangle is 0.5878. So what I do is I set this up as 0.5878. Now technically this is over 1. All right, so what this is the ratio of a 36-degree angles opposite and hypotenuse sides in similar triangles. So now that I have my ratio, all I have to do is cross multiply and solve. X times 1 is x. And then I have 15 times 0.5878. Okay, so I set up the proportion, I looked up the ratio in the table, and I'm going to solve, and I want to round the answers to the nearest thousandth for this particular one. So I grab my calculator, and I do 15 times 0.5878. Enter. So it's 8.817 is my answer. So x is going to equal 8.817. That's this side right here is 8.817. Okay. All right, let's take a look at the next one. First thing I want to do is identify my acute angle, which is this angle right here. All right, I want to look at the relationship to the sides of the sides I have to that angle. Where are they? All right, well, the 8 right here is next to the 59 degrees, so that makes it an adjacent side. All right, and then the x on this one is across from the right angle, so this is going to be the hypotenuse. Here's the right angle, it's across from it, so my ratio for this one is going to be adjacent to hypotenuse. All right, now, when I need to set up my ratio, adjacent, in this case, is 8. The hypotenuse is x. All right, now, I have to go to 59 degrees on the adjacent over hypotenuse column. All right, so here is my table. Adjacent over hypotenuse is the middle column, this one right here, and then 59 degrees is 0.5150. All right, it is this value right here. Make sure that you have the correct angle measure and you're in the correct column. So adjacent over hypotenuse is 0.5150. All right, so I need to flip back to here. Oh, wrong way again. Okay, I'm going to put 0.5150 over 1. All right, cross multiply and solve. 8 times 1 is 8. And then x times 0.5150 is 0.5150x. All right, solve for x. Divide by 0.5150. So x equals 8 divided by 0.5150. And I get 15.53, and I got to round this to the nearest thousand, so 534. So x is going to be 15.534. Rounded to the nearest thousand. That's what I got for that one. Okay, let's look at this third one. All right, here is my acute angle. And I have two sides, the 42 and the x. Where are they in relation to the 27 degrees? Well, the x over here is opposite, and the 42 is adjacent. All right, this one is across from it, this one is next to it. So we are going to use the ratio opposite over adjacent. Okay, so my ratio opposite over adjacent is x over 42. All right, now I have to look on my table column for 27 degrees in the opposite over adjacent column. All right, so here is my table. Opposite over adjacent is the third column. I want to look up 27 degrees. 27 degrees is right here. It's 0.5095. Okay, so I go back to my thing here and I put 0.5095 over 1. All right, so I have my two ratios. I cross multiply to solve. X times 1 is x. And then I have equals 42 times 0.5095. I put that in my calculator. 42 times 0.5095 is 21.399. So x is going to equal, rounded to the nearest thousandth, 21.399. Okay, so notice here, when we did this, you have to know the angle and what side you have in relation to the angle. Figure out which ratio you need, go to your table, go to the correct column with the correct angle measure, and find the missing value. Okay, now we can also do this to find the measure of the angles. So let's take a look at how to do that. All right, so to find the measure of the angle marked x to the nearest degree. This is the acute angle that we're looking for, but this time we don't know where to look in the column yet. So what we have to do is figure out what ratio column we have to look for. All right, so what parts of the triangle do we have in relation to this angle right here? Well, the 13 right here is sitting on, is the side it's sitting on, so that's going to be the adjacent side. Notice the right angle here, across from the right angle, is always going to be the hypotenuse. So we have to use the ratio adjacent over hypotenuse. That's the ratio we have to use. So adjacent over hypotenuse, in this case, is going to be, adjacent is 13, the hypotenuse is 18. All right, so we have to look in the adjacent over hypotenuse column for 13 over 18. But let's write 13 over 18 as a decimal. What is 13 over 18 as a decimal? 13 divided by 18 is 0.722222. So all of these are in 4 decimal places. So adjacent over hypotenuse is equal to 0.7222. So what I need to do is go to my table. Here's my table. I want to look in the adjacent over hypotenuse column, which is the middle column. I'm going to look at these numbers and I'm going to find the number that is closest to 0.7222. Okay? So if I'm looking here, 0.7222 is going to fall somewhere around here. Okay, so 0.7222 would be somewhere in there. All right, what number here is closest to 0.7222? Well, it's actually going to be this one. So this is approximately close to 0.7193, so it's somewhere between 43 and 44. So we are going to say this is going to be 44. All right, so all we have to do here is we are going to say x is going to be approximately 44 degrees. All right, so we find the angle in the adjacent over hypotenuse column that is closest to this value. I can't spell here, closest. Or I can't write, one or the other. Okay, all right, so if 43 degrees is 0.7314, 44 is 0.7193. That's the closest we're going to get. All right, so 44 degrees is going to be our angle measure. All right, so for your homework tonight, you are going to need that chart of values. All right, so when you work out the values, you have to be able to use that chart back and forth on this. So have this handy. It's posted on Classroom if you need to look at it. Okay, so that is finding angles using the acute angle and the ratios opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. They actually do have a name, which we're going to talk about in the next lesson, and your calculator actually has all those values, but I'll show you how to do that later.